In this video, we are going to define what a waveform monitor does, identify waveform monitor control and their functions, describe the NTSC signal, and identify its various components. Set a waveform monitor to a standard mode, measure burst, measure horizontal blanking interval, identify vertical blanking interval, measure sync, measure picture levels. A waveform monitor is a type of oscilloscope that is used to measure video signals in a production suite. Waveform monitors play a very important role in television production. It measures video signals by displaying them in graphic form on a screen. It can be used to measure the overall brightness of a television picture and other element of a video signal. There are a variety of waveform monitors, but for this video, we are using the Hamlet Videoscope 301. The input selection area has 5 buttons that control input into the waveform monitor. 1M, the high impedance BNC input on the rear. ABC selects input A, B, or C to the output. BNC Cal selects the front panel BNC or internal calibrator. EXT-Ref controls whether internal or external reference is used for the waveform monitor and vector scope. EXT-Vid allows any input waveforms to be keyed onto the external video signal, useful where the input signal is not a composite one. The display selection area has 5 controls. Scale controls the brightness of the graticules. Off mix removes the waveform display or provides a mix between picture and waveforms. Press the button repeatedly to step through the settings. FRZ STO controls the display persistence, normally standard 20 microseconds. Store is infinite persistence, and FRZ freezes the display. Watch the screen as you press this button repeatedly to step through the various settings. WFM VEC displays full screen waveform vectors, or vector or both. Press this button repeatedly to set through the option. Top BTM shows smaller displays at top or bottom of screen. This bottom has 2 positions, or top. Try it. The vertical selection area provides 4 controls that affect the vertical display of the signal. Gain varies the gain of the amplitude signal from 0.5 to 5 times. For proper use, gain must be set to calibrate. Shift. The vertical control positions the waveform vertically on the graticule for various measurements. Flat, L-pass, C-pass. Switches the display between flat luminance and chroma pass. Flat luminance and chroma, L-pass, luminance only, and C-pass, chroma only. Press the button repeatedly to cycle through the setting. BC lift adds a 350 MV step to inputs B and C for use with YUV inputs. The horizontal section area provides 5 controls that affect the horizontal display of the signal. Horizontal shift. The vertical control positions the waveform horizontally on the graticule for various measurements. 2V, 2 field. V, 1 field. 2H, display 2 lines on the screen. H, display 1 line. VMeg, expand the width of the sync on a vertical blanking. HMeg, expand and show the horizontal blanking. ABC and Filt displays ABC parade. However, we are only dealing with a composite video signal in this video. In vector area provides graticules display in a vector scope. Cal sets the gain of the vector scope section in unity gain position. Phase provides 360-degree rotation of the vector display. 75 to 100 controls the gain of the vector scope for 75% and 100% bars. PAL SW disables the 7.8 kHz PAL switch to give a 6-vector display. For our purpose, we will not be demonstrating the use of the vector scope. The scanning process. An NTSC video signal is a scanning process that sweeps out a series of horizontal lines from left to right. The electron beam scans the odd-numbered lines first, then it jumps back to the top of the screen and scans the even-numbered lines. The scanning of all odd-numbered lines takes 1/60th of a second and is called field 1. The next scan of all even-numbered lines takes another 1/60th of a second and is called field 2. The complete scan of all odd and even-numbered lines is represented by 2 fields. The 2 fields are combined or interlaced to make one frame. Interlaced scanning combines 2 lower quality fields to make a higher quality frame. In the NTSC system, there are 30 frames per second. Burst. Burst is a 3.58 MHz sine wave added just before the picture information on each horizontal line of video. It is a reference for color information with both hue and saturation. On the graticule, burst appears just to the right of the sync signal extending up and down from the 0 reference line. Picture level. Picture signal level represents the visible part of the picture that you see on TV screen. The blanking intervals. There are 2 different kinds of blanking signals, horizontal and vertical. As the electron beam scans each line, the horizontal blanking signal shuts off the electron beam as it retraces to the beginning of the next scanned line. The vertical blanking signal shuts the beam off as it returns to the top of the display, picture tube, to begin scanning the next field of video. Sync. The sync pulse provides of the timing control that keeps all video components synchronized. Setting WaveForm Monitor in standard condition. Before you can measure the sync, burst, blanking, and picture level components of the NTSC signal, you must calibrate the WaveForm Monitor into a standard condition. Let's assume that you have already connected all the cables. The sync tip should be seen near -40 IRE. Reference black should be on 7.5 IRE. Burst is between -20 and +20 IRE. And picture level should be between 7.5 and 100 IRE. Turn on the power to all of the equipment in the video production suite you are using. In the WaveForm Monitor input section, select whichever input to which you connected the test signal, A, B, or C. Turn off other inputs in this area and set the sync input to INT ref. EXT ref is not lit. In the display selection, set the scale to 12 o'clock. In the vertical section, set the response control to flat and turn gain counterclockwise to the detent position. Cal. Lights should be on. In the horizontal section, set the display control to 2 lines, 2H. Position the blanking level of the input signal on the 0 reference line of the graticule. Position burst just to the right of the numbers on the vertical scale of the graticule. Measuring burst. With the WaveForm Monitor set in standard mode, in the vertical selection, select flat, and then select the proper signal to be tested on the input control of the WaveForm Monitor. In the display color bars, you should be able to see 7.5 IRE, level of black or something close to it, on the waveform display. You should also be able to see a burst to the left of the picture signal. Burst begins at -20 IRE and extends to +20 IRE. This gives burst total amplitude of 40 IRE. The blanking intervals. Since there are 2 types of blanking interval, let's start by measuring the horizontal blanking interval. Make sure that there is a video signal higher than 20 IRE for proper measurement. Focus a camera on a white card and adjust the camera for proper white balance. Choose or set the control to 2 lines, 2H, Then select the HMAG. Position the blanking level at -20 IRE. Always remember this when measuring the horizontal blanking. Where the waveform crosses the graticules at the two locations is the horizontal B. Use the graticules to measure 1 microsecond per division. The overall duration should be 10.9 microsecond. If it is over or less than 10.9 microseconds, then something is wrong with the signal. Vertical blanking. Identify the vertical blanking interval. First select the color bar from a camera and then set the display control to 2V. Also set the mag control to VMag. Rotate the horizontal position control until you see no signals above 0 IRE. There should be 18 to 21 dashed scans. These lines represent the vertical blanking interval. There should be at least 18 dashed lines in total. They represent the 6 leading equalizing pulses at the 0 level, 6 vertical sync pulses at the -40 level, and 6 trailing equalizing pulses at the 0 level that make up the vertical blanking interval. There may be an additional 3 pulses at levels anywhere between 0 and 100. These additional pulses could be captioning, network queuing, or other broadcast test signals. Sync. Sync width is 4.7 microseconds. Setting a waveform monitor to HMAG, it expands the width of sync. After the sync expand position the sync tip at -40 IRE. So the width of the sync at a reference line, then on the screen you will be able to see a sync. Measuring a picture levels or picture signal. When we talk about picture signal levels, we are talking about picture luminance, information, or active video. This refers to the brightness of the visible image that has been scanned by the television system, whether it is by a camera or recorded to videotape. There are 2 things that you can check on the waveform monitor to ensure that the illumination of a scene equates to proper picture levels. There are reference black and peak white to measure the picture levels. Set up a video camera and connect the video output to the waveform monitor. Select the video camera output on the waveform monitor. Focus the camera on a subject. Make all required camera adjustments, including the setting of white balance. Position the signal from the camera correctly on the waveform monitor display. Blanking level must be on the 0 reference line. On the waveform monitor, set the response control to flat. Observe picture signal levels, including reference black and peak white. If the black level is not near 7.5 RE on the scale, adjust the camera's black level. Set the response control to L-Pass to view picture levels devoid of chroma information. If the whites are peaking too low, open the lens iris and